Hello, I'm Jared Skeens and welcome to the Zoom room. Today, we would like to cover the Pure Maths 1 Quadratics Part 2B of our Complete the Square. So last time in Part 2A, which was also about Complete the Square, we looked at the mental aspect, training the mind to understand what the Complete the Square is all about and how that little formula b over 2 squared, which I'll write down here again, b over 2 squared, how that comes about so that hopefully you remember it better. Now, in part 2b, I'm just going to focus on the skill. What do you have to do in the Cambridge question types in order to succeed at completing the square? Now, remember in the last part 2A, I ended it with a little outline of all the applications. Now, in the units quadratics, you're going to see it exactly as just a skill. In other words, you're not applying it, you're just doing it. So I'm going to demonstrate today in this part 2B the ways that you're going to have to do the complete the square. Later in further chapters or units such as functions, geometric properties of circles, and differentiation, you're going to have to apply the completing the square method in some sort of context. And you're going to have to learn when to use the complete the square method. So you need to learn the skill, how to do, and as you go, I'll let you know as we get there when the context demands that you need to do the complete the square in order for one of the various applications that you're going to use it for. So we saw in the part 2A, there were like 7 different things I pointed out that you're going to use it for, and the first one is in the quadratic section, and it's just simply doing it, okay? So I hope you remember the mental picture on how to understand where this formula comes from. And right now we're going to jump right into the doing of it. But first I want to point out that there are actually 3 levels of difficulty that we're going to face in the Cambridge questions. There's this first basic level. Notice all of them have this square, the complete the square part, but this one only has 2 other numbers involved. One number with the complete the square part, and then the other number that we pushed aside. And so these letters don't necessarily represent anything in the skill. They're just numbers that you need to come up with, and it's just in alphabetical order, A and then B. Later, when you get to the application, then those numbers will mean something. So in the part 2A, I said this B number, we don't care about it. It doesn't, mean anything. And what I meant by that is it doesn't mean anything with respect to the completing the square. It does have meaning in the applications, okay? So this first level just has 2 numbers that you come up with. This second level of difficulty, there's 3 numbers that you have to come up with. And then in the third level of difficulty, there's also 3 numbers, but this number that was outside, we then have to move inside. So you're going to see that the general procedure is the same for all 3, but as we move down these layers of, say, difficulty or complexity, you're going to have to take an extra step for each of these, or an extra couple of steps, in order to get it into the form that they require. They will show you the form that they want. So in the quadratics, this is obviously a complete the square. They give you a quadratic, and they also give you the form that will follow one of these 3 patterns. These are general patterns. You'll see that this can adjust a little bit, but it basically comes from these 3 patterns here. And so when you see that, you automatically know it's complete the square. So for quadratics, it's kind of a no-brainer. It's set up as complete the square. When you get into the applications, they're not going to show you this. You will have a quadratic, but they're not going to tell you that you need to complete the square. You'll need to determine by the context and the application that that's what you need to do. So it's really important that you understand the skill, and also as we move along that you also understand when this skill is used in which particular applications. Okay, so enough of that. Let's get started. Here is our first quadratic, and here is the form they give it to us. Now, if you remember in our discussion in 2a, this number 2 in our ax squared plus bx plus c, maybe I should first point out that the a in our ax squared plus bx plus c, maybe I should put that over here, our general form is like this. So one of the observations that we made in part 2a is we want this a to be a 1. And in this case, it is already an understood 1. So usually this easier form here is a form that already starts with a 1. It's these two forms where you actually have a number in the front, okay? So we already see that our a is 1, means we're good to go. And when we want to factor this, the 2 does not work, meaning when you take the factors of 2, you just get 1 and 2, and they do not add up to give you 6. Okay, so we cannot factor this, let alone get a perfect square. Okay, so since this number does not work, what we're doing is we're going to search for the number that does work. So we're going to write this as x squared plus 6x, and we're going to move the 2 over here because it doesn't work. That's very important that you move that number to the side first thing right away. It's not a part of our complete the square process, okay? Now what we want to find is this magic number that goes here, the number that does work to make this expression factor. Now you say, why do I put plus and minus? Well, this one is always going to be positive. Why? Because we're squaring. And whenever you square a number, regardless of what's on the inside, whether it's positive or negative, when you square it, it's going to turn out positive. And then this is the equalizer. So I'll explain that again in a minute. Okay, so here is, we're looking for the number that works. And if you remember from our visual representation that we did in part 2a, that we need to take half of this number. And so half of 6 is 3. So this is our b term, the 6. Divided by 2 is 3. Squared is 9. So our magic number is a 9. This is the number that will allow this part of our expression to factor. Now, notice our x squared is here, our 6x is here, the 2 is here. We have added a 9. We have generated a new number that is not in the expression, and we've added it in. Okay, but what we want to do is we want to maintain the value of our expression. So we need to equalize it, meaning we're going to subtract 9 over here. 9 minus 9 is 0. Our original value is preserved. But what we're doing is we're adding this 9 to the part over here, and we're subtracting this 9 from the part that we've pushed aside. So the overall value is the same, and we're just kind of rearranging the parts, okay? So now we can actually factor this. The factors of 9 are 1 and 9, 3 and 3. They have to add up to be 6. That's our 3 and 3. So this is an x plus 3 times x plus 3. And then this part here, 2 minus 9, is a negative 7. Now these factors are identical, meaning when you have the same thing multiplied by itself, that's the same thing as a square. So you can write this as x plus 3 squared minus 7. And if you notice, this form is the same as the form that they've asked you to put it in. So you can then identify your A is a 3 and your B is a negative 7. Now don't worry about these plus signs. All of these plus signs does not require the letter to be positive. It just means the letter is either positive or negative, and these positives are just like the default sign, okay? So it doesn't have to end up with a positive there. In this case, it ended up negative. That's okay. Don't worry about that. So this is how you do it. Again, you move the 2 over. It doesn't work. We find the number that does work through our formula that we discussed in part 2a. So the 6 is the b, divided by 2 is 3, squared is 9. We equalize it by putting minus 9 over here. This part factors. And so we looked at actually factoring in part 1. And so here you practice factoring again. You get x plus 3 times x plus 3, which is a perfect square, which is what we want. Complete the square. That's our goal. And then this part becomes minus 7. Now remember, for this unit, you're only doing the skill. You're not really doing interpretation or application with it yet. You will in the next unit when we get to functions. But for now, you're just demonstrating that you can do the skill of completing the square, okay? So that's our first example, and I'll set up again here for another example just so that you can make sure that you have it down. Okay, here's our second example. We're still on this basic skill level. Notice that this still has just 2 variables. There is one slight difference to this one compared to the last example, and they've put in a negative sign. Remember, these positive signs are default, meaning the A or B can be positive or negative, it doesn't matter. This has been supplied for you, meaning we expect to get a negative number here, but they've supplied the negative. So when you identify A, you're going to identify the A without the negative because the negative has already been supplied for you. So that's kind of an important detail. It can be a little confusing, but they are at least indicating for us that they expect to get a negative in this location. Okay, so again, remember, first step, well, first, make sure that your A is 1, which it is going to be for this easier version. We have 1 for our lead coefficient. Then we look at 8, and of course, we don't expect it to be able to factor because this is completing the square, kind of assumes it can't factor. And so factors of 8 are 1 and 8, 2 and 4, and you cannot add these to get a negative 4. Okay, so this number does not work. You can't factor it. So we're going to move that 8 over. That's the first algebraic thing that you should do if you don't have a lead coefficient out here. So we have x squared minus 4x. We want to keep that. We're going to move the 8 over because it doesn't work. Now we want to find the number that does work, and then we'll equalize it. So our b is now a negative 4. That's our b term. So our b term is a negative 4, divided by 2 is a negative 2. Negative 2 squared, positive 4. So the positive 4 is our magic number, and then that's the number we generated to introduce so that this does factor. Then we need to equalize it, so we put a minus 4 over here on this side. Now we can factor. All the factors of 4 are 1 and 4, 2 and 2. They have to add up to be 4, so that's going to be your 2 and 2, and it's negative, meaning it's a negative 2 plus a negative 2 gives us negative 4. So this gives us an x minus 2 times x minus 2. If you want, you can skip this step. Once you've done this a few times, you realize this is automatically a perfect square. So if you want to skip this part and go directly to the next, it's okay. 8 minus 4 plus 4. So here we have our x minus 2 squared. You can go straight from here to here. Once you understand that this factors every time into a perfect square, that's what we talked about in part 2a, that complete the square concept. So when you do this formula, it will always be a perfect square. Plus 4. Notice this now fits the pattern they've asked for. So when you identify specifically the values for a and b, the negative has already been provided. So your a is actually just the 2, okay? So the a is 2, the negative has already been provided, the b is 4. And so here we see 2 examples of this easier level of difficulty, and it's pretty straightforward. I hope that you really paid attention to that part 2a to give you that visual mental understanding, and hopefully you won't forget this very easy formula here, but it's very helpful, and it will help you be successful in these question types. So let's go into our next level, and I'll set up for that. Okay, here we go. We're now going to work on this second level of difficulty where we have 3 letters that we're looking for. Now we're going to start it off a little bit easier. If you look at the format that they want, they've actually already provided for us the first letter. But this is the second difficulty level. It's just they already show you what the A should be. Now you got to figure out how to get it there, and then you also have to find out the 2 remaining letters. Notice they don't call it BC, it's just in alphabetical order. So since this is already provided, this becomes A and then B. So really the -2 is our A, and we're finding the BC. Like I say, they just put it in alphabetical order. The letters don't mean anything particular in the skill. They do in the application. Okay, so what we want to do, again, remember we said before we want a 1 as our lead coefficient. We don't have a 1, so that's a problem. We also mentioned before that this number here does not work, so we're going to move it to the side. So the first thing that you actually want to do is move this number that doesn't work out of the way so that you can focus on the complete the square procedure, okay? So we're going to do the -2x squared plus 12x. First thing we do, we move that -3 over. Now, normally I put in the place for the magic number. I'm going to wait a step. We got to take care of this -2 first, okay? So now that we've separated this, we're only working with these 2 terms over here. This one we've pushed aside. We don't care about that anymore. So from this, we need to get a 1 as a coefficient, so we want to divide it out. And remember from part 1, where we talked about factoring, factoring is a form of division, except instead of putting it like a division bar, like a fraction, we move it to the front. That's what we're going to do with the -2. We're going to factor out that -2 and put it in the front. And so now I put parentheses, but remember factoring is dividing. -2 divided by -2 is 1. So now we have our x squared with the 1 as the coefficient. That's what we want. Now we have 12 divided by -2 is -6. So then I'm going to end the parenthesis here and put the -3 outside. This is what we're working with, and this is outside that we pushed away. Now I can put in room for our magic number, and then I'm going to put in a space over here, and I'm going to wait before I put the sign, because when it goes to equalizing it on this difficulty level, we have to pay attention to this A term. We didn't have it up here, we just put plus and minus, and it worked out nice. Now that we have an A in front, that affects our equalization. Right? So we want to find our magic number. We follow our formula. Our A is now an understood 1. Our B is now a -6. So the -6 divided by 2 is a -3. -3 squared is 9. So we get a +9. Now, you might think, well, if this is +9, to equalize it, we put -9. But you got to wait a minute. This 9 is now affected by what we factored in the front, because factoring is division. But if you expand this, mean you multiply it, this becomes -2x squared. This becomes a +12x. That means this would actually become a -18, not a +9. So when we equalize it, the opposite of -18 is actually +18. So this -2 distributes and affects our equalization. So -2 times 9 is -18, so we want to add 18 over here. So it might be worth your while to take that extra couple of seconds to distribute it back through and see what happens up here and equalize it up here and then bring that down so that you don't forget. A lot of people just put +9, -9 and make a mistake, okay? Now that we have that, now we can go ahead and factor. The factors of 9 are 1 and 9, 3 and 3, and the ones that add up to 6 are your 3 and 3. So this is a -2 times, this time I'm not going to split it into two separate ones, I'm just going to go right into the square. So this, to get a -6, it has to be a -3 plus -3. So this is an x -3 squared. You can always double check. X times x is x squared. -3 times -3 is +9. -3x and a -3x is -6x. So make sure you're kind of double checking yourself to make sure it works. -3 and 18 is a +15. Okay, so now we're in the form of what they want. We see the -2 we were able to get out in front. Now here, that positive is our, remember, default sign. And so this is a negative. So we need to put A being a -3 because they did not provide the negative for us. So A is a -3, and then our B is 15. Okay, so there is that extra step in here that we have to be concerned with in factoring out that lead coefficient, so that our lead coefficient is 1, and it does affect the equalization process as well. So here is our complete the square for this level, and just kind of a reminder in quadratics with a negative in the lead coefficient, what that means is that your parabola is facing down. So instead of an upward parabola, which is what you get when you have a positive number in the front, when you have a negative number in the front, means your parabola is going downward. Okay, so I'll set up another example so that we can make sure you get this down. Okay, here we go with our second example for this middle level of difficulty. And you can see right away that it doesn't look right. And that's because it's not. Cambridge does not always give you everything set up exactly the way it's supposed to be. They want you to do some thinking on your own. So the first thing that you need to recognize is this is not proper algebraic order. Proper algebraic order goes in decreasing exponential order. So we want decreasing exponential order, and remember the sign goes with the term. So here's our highest power, so it should be a -x squared, and then the -6x, and this is an understood +7. So the first thing I'm going to do is I'm going to put it in proper order so that it makes sense as we go through the complete the square process. The second thing I observe is their pattern is not exactly like the general pattern. So when I look at it, I see that there are two variables. It almost looks like this one, except there's a negative in front, meaning our lead coefficient is not a positive one. We want a positive one lead coefficient. So this is actually this level. It's just that our A is not this A here. The A in this, the one multiplying the square, is an understood -1. Again, they've supplied it for us. So you could write this as a -1 if you want to see that. X plus, here we'll just put the B squared. And this A actually could go in the back, and it's positive plus A. So they put it in alphabetical order according to left to right. But as far as the pattern goes, it's this pattern right here. The A is an understood -1, and then here's the letter here and the letter out here by location, okay? So this might be helpful for you in your mind to get what we're looking for, and then we can rearrange it to what they want at the end, right? So first, make sure that your pattern is right. Math is about patterns, and so you want to make sure that your pattern is set in a way that will help you succeed. Okay, so we did that first. Again, we're going to get that 7 out of the way. We've already talked about that. It doesn't work. We're going to move it over. So this becomes -x² minus 6x plus 7. Again, because we're dealing with an A, I'm not going to put in our little magic number yet, although I can go ahead and just write that in for now. But we're not going after the magic number yet. We got to get rid of that lead coefficient. So we're going to factor out a -1. You don't necessarily have to write the one, it's understood. I'm going to put it there for now so that you see there is a number there. And so -1 divided by -1 is +1. -6 divided by -1 is +6. And then we have the rest here, and then the +7 out here. This is where we want to put our magic number. It is always positive, and then we're going to equalize it over here. Again, I'm going to wait to see how the A affects that. So now's the time for the magic number. +6 is the B term. B6 divided by 2 is 3, squared is 9. We have a +9. Well, when we expand backwards, we get a -x², a -6x, and this becomes a -9. Which means to equalize it, we actually need to add 9. This -1 distributes to it, making it a -9 is what we actually put into our expression. So if we did a -9, then we need to add 9 over here. It looks like we're adding 9 twice, but this one is actually a -9. So it's a little tricky. Make sure when you have that A term in front, you consider that when you do your equalization part. Now we can factor it. We get a -1. Hopefully you already recognize this is the 3 times 3 to get 6, and it's positive. So we have an x plus 3 squared. 7 and 9 is now 16. And actually I'm going to get rid of our 1 because it's not necessary. And so we see that this fits the pattern. I'm going to get rid of that one there too. It's not needed. And so now we see that we have that. But don't stop there and identify your A and B. Make sure you put it into the form that Cambridge has requested. They want to see that you understand how to manipulate the algebra. Algebra is not just doing. It's about understanding what you're doing, and it's being able to move parts around. They only give you a general pattern, but you do need to be able to go outside the box a little bit. So we want to rearrange this. Notice the A is in the front. Well, that's the 16. And then we have the minus, that's this one over here. And then we have our x plus 3 squared, okay? So if you're looking at this, you might have, you might get a little confused. You want to make sure you're looking at this one over here. So the A is our 16. Here's our minus, here's our B, and our B is 3. Okay, so again, there's a few little tricks in there, but you should be able to handle those. The important thing is that you do the complete the square correctly, because it is a procedure you're going to be doing frequently in the units to come. Okay, so I think we've done 2 of these, and I'll set up for you the next example. Okay, here we have one more example, still in this middle level. This time they don't provide for us any clues. You don't see a negative sign. They don't give us the A value that we're looking for. So now we have to do the complete, this complete level on our own. So since you already have seen 2 examples of this, I'll go a little bit faster. So again, that's 7, move away. First step, get rid of that. Second step, we want to factor out the 3. Remember, we don't want that A term on there, so we factor out the 3. 3 divided by 3 is 1. Negative 12 divided by 3 is negative 4. We give ourselves room for the magic number and put the 7 here on the outside. Now we want to find the magic number, so we divide negative 4 by 2. Negative 4 divided by 2 is a negative 2. Squared is positive 4. Okay, now we need to double check to make sure we have everything. 3x squared, negative 12x. This becomes a positive 12, meaning our equalization part is a minus 12. So we got to look at how the A affects it. Gives us a plus 12. So we want minus 12 over here as our equalization. Okay, now we can go ahead and factor and make our complete the square. So we have 3x minus 2 squared. The factors of 4 are 2 and 2. That give us 4, and the sign is minus. And then 7 minus 12 is minus 5. Okay, so it's negative because the 12 is negative. So we have that, and now we can identify our parts. A is equal to the 3, B is equal to the negative 2. The sign was not provided, so we need to put it in there, minus 2. And then the C is minus 5. Again, the negative was not provided, so we need to include it. So there we go. That's the complete working out of this middle level of difficulty. We have one more layer of difficulty to go to, and we'll look at that here really quick. Okay, here we are set up. We're now moving down to this third and final level of difficulty. This one is the kind of the most challenging as far as difficulty level goes. And we can see it's what is asked for here by the Cambridge within this question. So actually, you're going to do everything that you did down to this point just like before. So let's go ahead and do that. Let's follow our normal pattern that we've established. We get rid of that 6 at the end. So we write 9x squared minus 6x. We don't want that 6 over there. Next thing that we need to do is we need to get rid of this lead coefficient. Now we're also going to see something else that we haven't seen in our examples. We're going to run into fractions. Don't let fractions make you afraid, okay? So pay close attention. This is the only example that we have for this difficulty level. It's got fractions in it. You could actually run into fractions in these other ones as well, just didn't in the examples. So we're going to take out that 9. Now when we take out that 9, 9 divided by 9 is x squared. Well, now we have a negative 6 divided by 9. Listen, don't let fractions scare you. They're just two numbers with a divide sign in the middle. If you need to, put negative 6 divided by 9 and reduce it, and you can divide by 3, you get negative 2/3. Or if you need to stick it in your calculator, you can stick it in your calculator as 6/9. You can use the little bar there and you can hit the equals. And when you hit the equals, notice it reduces it to 2/3 for you. Okay, so if you have to use your calculator, you can use your calculator. You can do it off to the side, but reduce that fraction down. Don't be afraid of it. So we have a minus 2/3 x. We're going to leave our space and we put our plus 6 out there. Okay, so I'm going to get this out of our way. Now it's time for the complete the square part. And notice our b is a fraction. Again, you can use your calculator if you want. So if you're using your calculator, you're going to use the 2/3. You don't really need the negative because you're going to square it anyway. It's going to end up positive. So no need to complicate things with the negative. So here you have 2/3, okay? And now you're dividing it by 2. Okay, for those, whoops, I put 8, dividing it by 2. Okay, so when you do that and you hit the equal sign, notice it says 1/3. When you're dividing into a fraction, it is the same thing as multiplying into the denominator. What I mean is this: we have a 2/3. We want to divide it by 2. Well, dividing by 2 is the same thing as multiplying by 1/2. Remember, division is the multiplicative inverse. Just like subtraction is the additive inverse, division is a multiplicative inverse. So dividing by 2 is the same thing as multiplying the 2 into the denominator. You get 2/6, which reduces to 1/3. You could have also have reduced it over here and get your 1/3. Okay, so you can either do it yourself manually, which you should be able to do. If you are in A-level math, you should be able to handle basic fractions. If you happen to have some weird numbers in there, you can use your calculator just to help your confidence level, but make sure that you have that right. So 2/3 divided by 2 becomes 1/3. 1/3 now squared. Remember, when you square a fraction, the exponent distributes to the numerator and to the denominator, and you get 1/9. So 1/9 is our magic number, positive 1/9. Now, when we check things, 9 times x squared is 9x squared. 9 times 2/3. Well, let's look at that again. You can use your calculator or just look at it. 9 times 2/3. You can see that the 3 cancels with the 9 and gives you 6 again. Yep, so a negative 6x, check. 9 times 1/9, what do you know that makes it nice again? 9 times 1/9, the 9's canceled. So actually we only added 1 to our expression, and meaning we need to equalize with a -1. So -1 is what we need down here. Okay, so we added 1/9 9 times, meaning we only added 1. We need to subtract 1 to equalize it. So I'm going to get rid of our rough work down here. We don't really need that. It's just making sure that we have the right values. Again, you can use the calculator to help you with that. Now comes the time for factoring. Now remember, the number right before we squared it was 1/3. Okay, you can go back and look at that if you want to. When we took 2/3 divided by 2, we ended up with 1/3. When we squared it, we got 1/9. So now we're factoring, and you're like, oh no, I can't factor with fractions. It's okay, don't worry about it. It's right here. So we have 9 times x minus, the sign comes from right here, minus. Now when we go to think of what the fraction was, remember we're making this a square, meaning we want the number before the square. Well, the number before the square is right here, 1/3. So you don't have to worry about what are the factors of 1/9, but it should make sense. 1/3 times 1/3 is 1/9. So I know it's kind of difficult to try to think of factoring fractions, but the number before you square it is the number before the perfect square. Okay, so this number is the same as this number. So if you're working with fractions, you don't even have to stress about it. It's already right there. 6 minus 1 is 5. Now we are ready to fill out our answers here. Oh, not yet, sorry. We have actually got to this point. Now we need to move into this extra level of difficulty. Here we're fighting fractions, and so that's a little bit new. But now we got to take this 9 and we got to get it inside this square. So the nice thing about Cambridge is when it comes to this more difficult level, what I've observed in the past papers is that they give you a pretty nice number to work with, meaning this number out here, when you get to this point, is either going to be a 4, a 9, 16, maybe a 25. They're going to be already a square value, meaning we can rewrite that 9 as a 3 squared. So they're going to give you nice numbers to work with. But if they didn't, means you'd have to work with a radical. But Cambridge has given you nice numbers from what I've observed. So this 9 we can write as a 3 square. We need to make sure that we have the same exponent before we combine it. Okay, don't just try to distribute it in. Multiplication and exponents are two different levels in our math operations. So we want to make sure that both of them are in exponent form. So we get minus 1/3 squared plus 5. Now that we have the same exponent, now what we're doing is we're following our rules of exponents backwards. What you saw before is this. If you have an A times a B squared, you distribute, exponents distribute over multiplication, and you get A squared B squared. Okay, all we're doing is we're going backwards. Instead of distributing the exponent, well, I guess we're undistributing the exponent. Kind of like factoring, but factoring out the exponent. I don't think that's technically correct, but I don't know that undistributing is actually the right word either. That's the word I'm going to use. So instead of distributing the square over multiplication, we're going to undistribute the square. We're going to take it back. So we're going to take our square back, and that means the A is times the B, and we put the square back on the outside. Okay, we undistributed it. So that means our A is the 3 and the B is what's in the parentheses. So if we undistribute it, it means it's the 3 times our x minus 1/3. So 3 times x is 3x, and 3 times the 1/3 is just 1. And there we've undistributed the square. We've taken it out, and we've multiplied the two parts. In this case, the 3 is being multiplied by the x minus 1/3. So because it's multiply, we distribute it over, add or subtract, and then this plus 5 just stays plus 5. So here we have extra 2 steps that you have to take from this level to this level, turn it into a square, undistribute the square, and when you multiply in, of course, now it's multiplication to add or subtract. That also needs distributed. So we're undistributing the square, but we're distributing the multiply through. 2 extra steps. Just adds a little extra work on your part but you can get the answer. Now we have A equals 3, B equals a -1, and C equals 5. So here we go. We're at the end of our part 2B of completing the square, the skills part, that is how to do it algebraically, following our algebraic system at 3 different difficulty levels. So make sure you really get this skill down. All 3 levels. I would say this one occurs only once in a while. These upper 2 are most important because they're the ones that you're going to use for the applications. These are the ones that fit the applications a little bit better as we move forward, but you still should be able to do this. It does occur once in a while. And get this process down, okay? Take your time, work through it until it becomes like a habit for you that you can successfully do this, because again, you're gonna have multiple applications of it, and it's really sad to see someone struggle with a different, new concept when they haven't mastered the old one yet. It makes it doubly difficult for you. So take your time, but get it right, and you'll be well on your way to having a successful journey through the Peer 1 math book. Okay, so thank you for joining me, and I'll see you next time for part 3 of our quadratic series.